Welcome and thank you, James. It's really, really glad to have you here. One of the joys of my job that I've done is talking to customers and learning how they use SingleStore, right? We build a database and we put in incredible amount of time and effort and diligence in building this database. But what really matters is if customers get value from it. So, first I want to thank you for being a customer. Thank you for taking time out of your busy schedule to talk to us today. And for our audience who doesn't know about some of the amazing things that Heap does, could you start by talking a little bit about Heap?
Yeah, absolutely. Thanks, Yathat. So I'm James. I'm a staff software engineer at Heap. I'm the architect and lead on our migration to SingleStore. So for those of you that don't know Heap, Heap is a platform for understanding what your users are doing with your product. So our typical users are product managers, marketers, account managers, and so forth. And what our product does is we collect a lot of data about how your users are interacting with your product on behalf of you. And then we provide different visualizations and tools in our app for you to understand what's going on. So we started with kind of traditional product analytics, funnels, counts over time, user activity by refer, and so forth. But since then, we've expanded to do session replay, heat maps, managed warehouse ETLs out of our system and into our customers' Snowflake, BigQuery, Redshift warehouses, and so forth. Traditionally, our big differentiator for a long time has been that unlike the traditional analytics model where you have to make a tracking plan and decide, I want to track these interactions on my site ahead of time and then get an engineer to do it, we collect all the data for you ahead of time automatically. We collect all the interactions. And then when you decide, I want to go and look at how my logins are changing over time, you go to a section of our application and say, events that have a click on a button with text login, that's a login event. And I want to be able to look at that and I want queries on it to be fast. And you'll have the full historical data set available to you. So this is a lot better for our customers because instead of, oh, I forgot to track this, let me go ask an engineer and then deploy it. And then I'm missing data up till now. I only have the data going forward. You have the whole retroactive data set. But what it means is we have a very demanding data product. We ingest a lot of data and our product has to scale accordingly. So a couple numbers here on the scale of our data set. So we store petabytes of data compressed, and our compression ratio is 80 to 90%. At peak volume, we're ingesting hundreds of thousands of events per second. We store trillions of records, literally. With our current indexing approach, we're managing tens of millions of indexes in production. And the queries that we're running on this data set are not simple. These are true analytics queries. We have customers with tens, hundreds of billions of records. Individuals' queries may scan up to billions of records, terabytes of data. So you can imagine that the database and data system that powers this has to be very well tuned and very performant.
Thank you, James. That's very, very impressive. And by my count, you said queries about 7 times, which makes us happy because you need a product that can actually allow you to run these complicated queries. Also, very impressive and something I didn't know that I didn't have to know the questions before regarding the data. Like I could record the data with Heap, and I could figure out what questions I want to ask later. So that's very, very interesting. Can you tell us a little bit about some of the challenges that you saw before you came to SingleStore with your data platform?
Yeah, so for the past 7 or so years, historically, Heap has been built on Postgres and then a combination of Postgres and Citus. For those of you that don't know Citus, it's a layer on top of Postgres that allows you to essentially build a distributed Postgres database. It distributes Postgres. So I just want to say up front, I love Postgres. I love Citus. Postgres is a very impressive piece of software, but fundamentally, we've run into a lot of problems over time because Postgres and Citus are designed to be transactional databases. They are designed for traditional transactional workloads, point updates, point inserts, look up specific records, and so forth. And we have a true analytics product where we are running analytical queries, scanning tons of data, billions of records, and so forth. We've kind of worked around it with our indexing approach, but this has been at the root of a lot of the challenges on this page. So just going in order, query perf historically has been a constant challenge. We've had a team for periods of time just dedicated to improving performance. This stems from the transactional nature, and in particular, the fact that Postgres is row oriented. If we run a query only scanning 2 columns, well, for a lot of our queries, we actually have to read all of the data that's being scanned instead of just those columns. We've worked around that by abusing Postgres's index-only scans, but for a lot of our queries, we can't. And that's been a big issue for us. Another issue is that because of the transactional nature of Postgres and Citus, it's not really optimized for shuffling large amounts of data around. And there's a lot of queries that we run or would like to run that require us to shuffle large amounts of data. So we've actually just built the system in a way where we avoid features that require large shuffles because of the performance challenges there. In terms of operability, like I said, we have a unique indexing approach to make queries fast, and indexes are great on the read path, but they come at a cost on the write path. Write throughput has been a challenge for us basically for the whole time I've been at Heap, which is almost 7 years now. When we have tens of millions of indexes running, writing to all of them and keeping them up to date is expensive. Other thing with operability is Postgres has coupled storage and compute. So if we have one workload that's doing operational stuff in the background, that needs to run on the same hardware as the queries that our customers are running that are production critical, that are customer experience impacting, because all the data is just in one database. This has caused business problems for us. I mentioned the features that we just haven't built. We've actually lost revenue because of that. There's whole classes of analyses that we haven't been able to implement that our customers have asked for, and some have churned as a result. We've also been constrained in moving up market to customers that send us higher and higher data volumes, just because with our performance characteristics, we've always had a cap on the maximum size of a customer that we can support. And the last thing I'll mention is just with coupled storage and compute, without the ability to have S3 as the durability layer, our costs are driven by SSDs, and SSDs are important. As our data set grows, as our customers are with us longer and longer, our costs grow and grow. And this has been a problem for us in terms of just keeping our margins up, pricing, being competitive with other solutions that don't have this coupling of storage and compute.
Thank you, James, for sharing that. And I agree with you. We love all databases here at SingleStore, but some of these problems that you're describing is at least the problems that we aim to address. So, when you started running into these issues, how did you go about looking at an alternative to address these challenges?
Yeah, happy to talk through that. As you know, Darth, we went through a very, very lengthy work-intensive process. So we'd known for a while that we were going to need to move to a more modern system that's more capable of supporting high throughput analytics workloads. So we knew we wanted something columnar. We knew we wanted something that decoupled storage and compute. We knew we wanted something with shuffle performance. And we also knew that with the size of our data set and just how many queries our product can run, that this was going to be a really lengthy and difficult migration. It was going to be a big investment. So we wanted to be very thorough upfront in terms of vendor evaluation. We didn't want to just pick the first thing we saw and then 6 months down the line realize, oh, there's actually a big problem here and we need to go back and redo everything. So we started with kind of a broad survey of a bunch of promising databases or analytics systems. I've listed some of them here. Some of them are not listed here. So we started with that broad survey and we had some idea of the requirements, and we did some initial testing with each of those and then rapidly started eliminating a lot of them. And a couple somewhat surprising but common themes as we went through these technologies started to emerge. So the first one was our product runs some pretty complicated analyses that are actually very difficult to express performantly in SQL. So historically, we've really needed the ability to put procedural code in the database and run it from our SQL interface. And some of the analytic systems that we looked at just didn't have that capability. So we tested it out, and it just ended up being a huge hassle to actually implement all the stuff that our product supports without procedural SQL, without the ability to define UDFs. So that was one theme amongst all the things that we were looking at. The second was that a lot of these data warehouse like OLAP systems were designed with traditional OLAP workloads in mind. And in particular, they were designed for everything is denormalized onto a single table. You're not really doing many joins, and you're running queries that kind of match the MapReduce paradigm where everything is pushed down. You don't need to repartition. You're just dispatching jobs to worker nodes. Those workers do some aggregations, and then those aggregations are merged on some sort of coordinator node. And if you can keep your workload to those sorts of queries, these solutions did well. And this is actually what we've had to do historically with Citus. But we wanted something more flexible to build these new features and so forth and not be hamstrung into a certain type of query. And we found that a lot of these OLAP systems did not fully support distributed joins, or they were really poorly performing when it came to repartitioning. So that was kind of the second theme that allowed us to eliminate some of these solutions. The last thing that we realized, and this is more specific to our business, is that infrastructure is a very big cost for us. We are very data intensive. We store a ton of data. Our AWS bill is probably our single biggest cost component. And we realized in looking at the pricing for a lot of these tools that a managed service was probably not going to be economic for us in terms of the level of margin that we're aiming for. Just adding another layer of margin taking in between us and our customers meant that we would need to raise prices significantly for our customers. So the ability to self-manage, run our own hardware was very valuable for us.
Yeah, and we talk here a lot at Single Store. We want to be the one single store for all of your data, but at the same time, we also want to make it available where you are, and that's why we produce both of those offerings: a fully managed offerings for customers who want that, and a software only offering that you can run in a self-managed way. So glad that you appreciate that. What else? Could you drill down deeper into what aspects of Single Store went into your decision?
Yeah, so it shouldn't be surprising based on the requirements and kind of the limitations I've talked about so far. But single store basically ticked all the boxes that we were looking for. So, like I said, it's a column store. It has decoupled storage and compute with the bottomless offering. A fun fact is that we had actually kicked off a previous iteration of this infrastructure revamp a couple of years before this proof of concept and migration. And we looked at single store then, and single store also performed the best then, but bottomless was not yet a thing at that point. So it didn't have decoupled storage and compute. It wasn't going to fundamentally change the economics of our business. So it wasn't something that we could prioritize at the time. But now with bottomless, we have decoupled storage and compute. I'll come back to query performance, but single store, much faster data ingestion than our current system, and it has the self-managed option. On the query performance side, so single store really impressed us in particular with its query execution primitives. Scans were just blazing fast, repartitions blazing fast. There were some other parts where there were sharp edges, but overall, underlying primitives incredibly fast. We've talked ad nauseum about repartition so far. One other thing that I wanted to call out that we saw as a really nice advantage for single store, and actually what kind of makes our design work right now, is hash indexes. So I think in the docs and maybe in marketing material, hash indexes seem to be positioned as more of a transactional feature. But for us, they're actually incredibly valuable on the analytics side. And if you think back to how our product works, where I was talking about we ingest all of the data and then our customers tell us what swaths of their data set are interesting and then run queries on those particular swaths. Hash indexes are particularly amenable to that sort of workload where we store all of the data in one table and then our customers go back and say, hey, actually, clicks on a button that says checkout, those are checkout events. Well, for our biggest customers, without hash indexes, even though scans are fast and checking an equality predicate is fast, if we have to scan 50 billion records and check this equality predicate against every query, it's not going to meet our performance requirements. But with hash indexes, we can, for example, put a hash index on target text. And now if you do a filter target text equals checkout, we can basically get O of 1 access to the subset of rows that match that hash index. So it is a big differentiator for us with single store, and it really makes our schema work very well for just identifying, ripping sparse subsets of data from disk, and then proceeding to the rest of the query plan.
You know, James, that right after this goes live, my marketing team is going to be reaching out and they're going to want a primer on hash indexes now that you spoke about it. But no, this is one of the interesting things about single store, right? The fact that you can do analytics and transactions in the same system in the same data doesn't mean you can only do those two workloads. It opens up net new opportunities, like what it's done for you. Same thing with the ingest. The reason ingest is so fast is because we write it in a specific format in memory when the data comes in. That's how you're able to get that data in an incredibly fast manner. I was talking to Kate earlier in the session, and I used the word delightful a couple of times, and she caught on to that. We want to make sure that our experience, your experience with us, not just with our product but with the company, is delightful. So can you talk a little bit about how the journey has been, even outside of the product? Like, have you interacted with people? Have they helped you out? Are there problems I can help with?
Yeah, it's been great for us. I hope y'all would say the same. I know that we are certainly not the easiest customer that y'all have ever had. We are definitely very demanding. But yeah, starting with the POC. So as I talked about before, the POC process was quite long. I think it was somewhere between 3 and 5 months from when we actually kicked off the process to wrapping up the POC and signing a contract. During that time, SingleStore was basically a partner for us throughout the entire process. We had a Slack channel set up. Engineering was jumping on to help us with query plan debugging or configuration suggestions. It was basically an open communication with weekly synchronous meetings throughout the entire POC. It was just incredibly helpful throughout, and we definitely wouldn't have been able to make it through the POC and solve all the problems we did without it. Since then, we've been implementing the design for about a year now, and we're in the data migration phase now, and that process has only continued. Y'all have been great partners for us. The responsiveness and help with random questions and issues that we have has been just incredible, and y'all have even worked with us and partnered with us on building or enhancing certain features. I know that we have been a particularly demanding customer as far as our JSON workload. So y'all have been super helpful with building enhancements and so forth for that. So overall, nothing but good things to say. The last thing that I would add is that single store support has been great as well. And in particular, we've been able to say, we have a migration coming up at this particular time, or we're going to be doing a critical operation at this time. Can y'all have someone around just in case things go wrong? And y'all have been super flexible with that as well.
Now, thank you for that, James. We pride ourselves in thinking about our customers as partners. Databases, in our opinion, form a part of your product that you sell to your customers. And we want to make sure that both you and them have a great experience, with single store. And you'd asked this question at the beginning of this slide. We too think of Heap as great partners, not just our customers. We certainly got to learn a lot. In fact, you were one of the three customers that inspired us to like triple down on our investment in JSON. And as we went through that, we learned a lot. We built Kai, so you have a strong part to play on how we got started over there. In terms of your implementation, like where are you right now, and what are some of your plans for the future?
Yeah, so this is a very high level view of how our infrastructure works and how single store fits in. So this kind of lays out the end state. So single store essentially serves as the query layer on top of our data system. So the data lives in single store. The query flow when a customer runs a query from our app is the app sends a JSON payload to our app server. The app server compiles it to SQL, fires it off to single store. Results come back. App server post processes it and sends it back to the front end. You can see in this diagram, though, we kind of have this new bifurcated setup with our infrastructure, whereas previously Postgres was both the query layer and the fundamental durability layer. Now we have our shared data lake as our durability layer, and single store is basically the query layer that serves all of these interactive queries that need to be fast. The last wrinkle here is that for some definitions that our customers create, if a customer tells us this particular slice of my data is interesting, some of those definitions, we cannot serve them really quickly with hash indexes, that they require a like or a regex or something that would be kind of slow. So we have this materialization system that whenever one of these definitions is created, we kick off a Spark job to get all the relevant records from our data lake and ram them into SingleStore. And this works really well for us, particularly given SingleStore's really fast ingest throughput. I think this also kind of illustrates the versatility of being able to just pull data off Kafka, but also down from S3. So this is kind of the end state architecture. All this is done. The end state system is up. We obviously still need to scale up. And we are in the middle of migrating our existing data set to SingleStore. So for customers that have joined us in the last quarter or so, they've all been automatically onboarded to the system and we're running their queries. And we're in the process of getting our multi-petabyte data set out of our lake into SingleStore and cutting those customers' queries over. So we expect that for the next several months, we're still going to be running in dual operations mode where data is going into our legacy cluster and our SingleStore clusters. But after that, we expect to be totally migrated. Last thing I'll call out here that's been really nice is with SingleStore, it's been super easy for us to switch to a multi-cluster model. With our Postgres setup, we have one big cluster that serves the vast majority of our customers. With SingleStore, we've switched to multi-cluster, and this allows us to not only limit the blast radius of if one customer is running a lot of really expensive queries and causing contention issues, now it only impacts a fraction of the customer base. It's made us really easy for us to expand to the EU and set up SingleStore clusters in the EU for data for customers that want their data only to be located in the EU.
No, that's very very nice to hear about some of the things that you can do with SingleStore, and there are certain interesting things in our roadmap which should help you out where the hash indexes don't work. So more to come over there. Really appreciate you sharing this architecture. You mentioned that some of your customers are already on SingleStore and you're in the process of migrating the others. With what you have done so far, what are some of the technical and business outcomes? Like, how would you characterize them?
Yeah, so overall, the results have been very good. Um, I'll talk through kind of my favorite boxes on this slide. I won't go through the whole thing. So in terms of the technical impact, I am most excited about the top two. So like I mentioned, historically, data ingest throughput has been an issue for us. Now it's not an issue at all. So typically during peak hours on our legacy system, we were seeing ingest latency on our highest latency Kafka partitions peaking around 30 to 60 minutes during peak hours. Now with SingleStore for the whole day, it's typically 1 minute end to end. And it's not even like the SingleStore ingest is lagging. We just have many layers of Kafka consumers in between the edge and SingleStore. So a couple seconds here, a couple seconds there add up. Queries have been really fast as expected. So for customers onboarded to the system, we're seeing typical queries of a second or less, like P95. The 5% of queries maybe are 2 or 3 seconds or above. So overall, incredible query performance. The thing that I'm actually the most excited about, though, and I alluded to this before, is the box on the left on the bottom half of the page, and that's the unlocking of new features. So as I mentioned, we've historically had this backlog of features that we would love to build, that our customers would love us to build, that we just couldn't build because the data system didn't support running these queries performantly. Now we've entered kind of this phase of rapid innovation and new feature development because we all of a sudden have this backlog of features that we can just start work on immediately. We know what we want to build. We haven't been able to build it because of the database in the past, and now all of a sudden we can just build all these things. So that's what's been most exciting to me, is seeing kind of the new features unlock that we've wanted to build for years.